Farid. So, for those who don't know me, my name is Katrina, and I'm CEO and co-founder of a company called Civic. Civic has been around for 7 years now, so we're really old, but we've been working for a long time in this industry. And one of the areas that we're known for is our work around natural capital, which is fascinating given that everything is now about ESG and you can't turn left or right without somebody sticking a carbon credit into your face and telling them that they want to blockchain the hell out of that. Not that you want to do that but anyway, so we do the same thing, but we do that with water, and we have been doing this for the last 5 years. So quickly, what is a water market? For those who live in Australia, water markets are the markets that our farmers go to get access water. They're given an allocation every year. That water is then used to grow our food, but there are limits around those rights, so water does not exceed the sustainable yield of water resource systems. For people who are from New South Wales, you'll be probably very familiar because every other day a farmer has been accused of taking more water than they are allowed. Just the value of water in the Murray-Darling Basin, $6 billion, so we're talking about a significant amount of water that is traded. Water is not a financial product, and therefore there is no real world accounting systems that account for our water in Australia or globally. So, meet Joe. This is one of our customers that we're working with in Far North Queensland and Tablelands. I'm from Queensland, so this is in Cairns. So if anyone has been up to Cairns, one of the most beautiful places is the Tablelands, where they grow 20% of our food, being mangoes and avocados. So Joe, and like most farmers, they just want something that works like a share market. They just want to basically go into a share market experience, put a bid, make an offer, and be satisfied and feel confident that that trade is going to occur. That does not work in the way the world works now for water markets. But they want to see price discoverability. Yes, it's very difficult to actually find the price of water. It's like going to the share market and looking at the Australian Securities Exchange and nobody's actually telling you the price of the share. And you've got to go pay a water broker to find that. So these are all these things that we have been working for the last couple of years, and now we're working with one of the bulk water providers in Queensland, and now I'm going to interview Farid because this is the work that we do. So basically through the lens of tokenization, so yes, we've been using tokenization for many years, NFTs, all that sort of stuff, but we use it for real world assets so we can account for them. And Farid's going to talk to you about what that involves. So we have an accounting system, so we can actually tokenize entire water schemes, and then we have a community water exchange. And the most important thing for water markets, and for most of the reasons why we use blockchain, is to create an audit log. Those audit logs are critical because it gives the public window to how a water market is operating. Right now, there are no windows for public, for you or for me to go and look and see who owns our water and how is that water being traded. So, over to you, Farid. So, yep.
Yes, hello everyone.
So Farid's going to introduce himself to all of you, and if you can just give them a little bit of background about your time here at Monash.
So yeah, I studied my master's here in Monash in information technology 2 years back. So I attended my last semester here in this campus. It was in COVID, but it was we are back again to speak about our product. Also work with Civic for 2 years. It was really great. So I'm gonna share my screen to demo the water ledger product that we have made.
So what Farid's doing is one of the things that we do as a company is that we're a software development company that happens to build our own product with blockchain tech to solve a real world problem, but we still have to be a software company, so agile, like all those things that you learn at uni right now about how do you actually run a sprint, how do you actually develop a user story, how you run that sprint, you do your retros and all that sort of stuff. We have to work like that as well. It is one of the most important ways that we operate as a company to actually work in sprints, so we know what the definition of done is, and what we're actually iterating and what we're going to be shipping at the end of the sprint. So what we're seeing here is the customer interface for Southeast Queensland Water. Southeast Queensland Water is our bulk water provider. If anyone knows Brisbane and knows the Ivanhoe Dam, which is the thing that floods Brisbane when we have a flood event, that's SEQ Water. They basically are the managers of our dams, but they also have 7 water schemes that provide irrigation water for our farmers in that region. So we've been working with them on the Central Lockyer Valley. That's one of the most complicated water schemes. Their water year is different, and we have been working with them from taking them from an Excel spreadsheet to blockchain. Now, for most of, we know that that's insane. How do you go from an Excel spreadsheet to blockchain technology? Well, there's a lot of theory of change going on in the background to move them from this state to another state. It's just not about blockchain, it's really about our engagement with them, which the team actually do with SEQ Water. So over to you, Farid.
Yeah. So as you can see, we have a scheme setup, which is about Central Lockyer Valley scheme, and you can see the allocation announcement for the zones. So scheme is basically a bigger water body than zone. So we have set up the hierarchies of water bodies. So we tokenize the water, the physical water, as H2W, and then we have the right. We have tokenized the right as well for the irrigators. So irrigators have a nominal volume of water that they are allowed to use, and we have a title token that is minted for the subscribers or the irrigators. So when SEQ Water does the allocation announcement, that is basically saying amongst the nominal volume that the irrigator have, you can only use only the 80% of it, or maybe 60% of it. So once they've done the allocation announcement, we move the physical water to the subscribers bucket, as token. So we move those bucket as token. So behind the scene there is conversion pool that is happening. So the conversion pool is a mechanism where we exchange the subscriber right, and we give them back the water, H2 water tokens. So you can like compare it with like cash transaction, foreign transaction, for example, USD to pound. You can compare the same way, but we have built up the mechanism to convert the H2 right to H2 water, and then we move the physical water to the offtakes or the buckets of the subscribers. In the system we have basically set up the.
So what happens every year is that the water authorities, and this happens in the Murray-Darling Basin as well, is that every year the water has to be reset. So all the accounts in every irrigator's account has to be reset. So it depends if we've had a rainfall event for that summer or not. So when we say allocation of 80%, means that there's only so much water in the system that can only be extracted not to exceed the sustainable yield of that water thing. So at the start of the water year, the authority has to make that announcement. How much water will you get? If I have a water right to say that I'm allowed 100 megalitres, but only 80% will be announced, that means I can only get 80 megalitres against my account. When we go into drought, you find that irrigators get about 20%, 10% of water, and then they've got to go find ways to grow our food. But it's a really important thing, because this means that water is accounted for in every account based on the allocation announcement, which we call the exchange rate, which goes into the consumptive pool, which is then converted for wet water into dry water into wet water, then moved down to the extraction point so farmers know how much water that they're allowed to take. And this is the world where it gets very complicated for developers like Farid.
So at the moment you can see in one zone, which is the second layer of water body, the zone. So there are multiple priority, like low priority, medium priority, and some of the customers have priority like stock and domestic, which has to be used first and then move on to the second priority and then move on to the other priorities. So we have also made up a mechanism where the water are used based on priority or H2 water that is moved to the extracted wallet based on the priority. So we know exactly which amount of low priority water has been used, which amount of stock and domestic water has been used. We can track that. We have like for each of the buckets we have created wallet that can hold the H2 water, and we can move those water to the water extracted account that holds the tokens of H2 water. So this is how we are tracking very minute level each and every liter of water that gets moved from throughout the supply chain. For example, from scheme to the zone to the offtakes to the extracted account.
So what we're doing here is now, this is very complicated. The reason why it's complicated because there's 10,000 business rules that govern water in Australia, 10,000 business rules. Water is not homogeneous, it's a heterogeneous product with about 350 products. So what Fahad just explained to you is around a priority. So there's stock and domestic, which is a low priority, then you have a low priority, medium priority, high priority. Against the business rules in the water plans, irrigators got to take their lowest priority water first through the meter. Then they take the second, and then the third, and then the highest. Now what we do is we automate that. So the farmer does not have to monitor which priority water goes first. We're doing that for them. So that means that they don't have to worry about being a breach, or getting a fine, or being advised that they're actually exceeded their allocation against their accounts. So what we're able to do is bring this thing called, I guess, a level of trust and confidence to the irrigators, knowing that their water accounting system that we built with blockchain tech and all the hard work we've done, it takes that away from the farmer. They can just get on and do what they have to do, is grow our food. But it's very a lot of work from our team particularly, and I think which I'm going to ask Fahad to explain, but from a student perspective, when you think about going into the real world and thinking, I want to be, to work in a development team with a blockchain company that solves problems and things like that, how you operate as a team is extremely multidisciplinary. You have to have people who have subject matter expertise of the problem, but you as a team have to work closely together to say, how do we solve this problem? So Fahad, I know that some of the challenges that you've had has been around just even the concepts of a forward draw. So customers are allowed, if they start to exceed the running out of water from their account, they're able to go into the future and pull 20% of their water from the future year into the current year. And then when the water year is reset, you have to rebalance the accounts, but it's based on the allocation percentage of the forward year that you have to rebalance all this stuff out. Now, Fahad, you've solved that problem.
Yes. So we face an interesting problem where the tokens of for example, of 2021, which is like a set amount, but some of the customers might forward draw, use the water of next year. So we have built up the mechanism whereby they can mint the token early, use it, and then rebalance it for the next year. Yeah.
But to do that, we've had to work as a team around workflow and logic, and working through the lens of digital wallets and tokenization and characterizing, giving classifications of water into a data table. So when we're working with a customer, and this is very normal, like if any of you are going to go when you finish university and you start working in a startup like us, you are going to be dealing with customers with Excel spreadsheets. There's no luxury that they're going to have their data in a database and then hand it over to you and say, now let's work on blockchain together. It's very, very lucky if that happens. So we've had to work directly with Excel spreadsheets where people have used their own brains to actually create a logic in a spreadsheet and then then they come to us and say, code that. But here are the 10,000 business rules that you have to understand, and here's the regulation and the law and everything that you have to do. So when we talk about why do we use blockchain technology in this regard, did you want to show them about why blockchain technology is so important when it comes to water?
Yes. So when it comes to transparency, especially, you can see how much water you actually have for each of the zone, and like when we go to the water market where we have the buyers and the sellers, you can like track and see the transaction hash for each of the amounts of water that you have used, or so transparency is one of the thing. And also you can calculate to the liters of water. Right now it's all megaliters, but you can like account for each and every liters of water with the help of blockchain.
And when we are dealing with water, particularly, and we've got La Nina leaving Australia now, we've got El Nino on the way, our farmers are going to go back into drought. So we need to account for every drop of water so we can still sustain water for the environment, but also water is a core data point into the carbon economy or the zero carbon economy. If you are a miner and you're doing critical minerals, you need to have a license to extract water. So you have to have a license to extract, and you also have to have a license to discharge. Where we worked with Everledger on the critical minerals project, the big, $1 million, how much was it? I can't remember, it was a $2 million, I don't know, we didn't get much, but Everledger got most of the money. But we worked with Everledger on how do we actually assess the rules of water at place when a miner's taking their water. And we were accounting for it in real time through rules that was coming as raw data from Everledger's platform. They use Hyperledger, we use Dera. And then we're able to use the rules and actually make some sense of that water data in a raw state to verify that it's compliant, and then share that data back to Everledger to inform an ethical passport to verify in the supply chain how much water has been used at site to create that commodity called nickel. So the premise of this is that we are creating a provenance of a watershed which has multiple beneficial uses such as agriculture, urban, but we also need to know who has what, who has the ownership across those assets. So by leaning in on tokenization in the first instance, the team are able to ensure that not 1 megalitre or 1 litre of water can be presented in any one bucket or account at any one time. So we can only find 1 megalitre of water, its ownership, its provenance, its characteristics in one account. So water can never be double spent, and that's what happens today. If we go and have a look at the way water markets work or water accounting works, you find that water has been double counted. So this is why we have the magical problem of the 450 gigalitres of water that our government's trying to buy back, is because nobody knows how to account for this water. So from your perspective, Fahad, so when we actually finish tokenizing, and we haven't used smart contracts in this particular application just yet, and the reason why is that we don't use the tech if we don't need it. Why would you want to? If this is a level of tokenization, we can actually build the rules in, but when we go to doing the exchange,
we're gonna use it. Yeah. So when we have like parties which needs to be verified, like the buyer and the seller, in that scenario we'll be using smart contracts for example the trading platform, the phase 2 of this water ledger. In that scenario we will be using smart contracts because there will be a lot of business logics that needs to be coded, so it's better to do it with the smart contracts. In this scenario where it can be done, like for example minting of tokens or transferring it can be done really easily with the traditional SDK, using the other SDK, so we didn't bother to use the smart contracts. So yeah.
And I think one of the other things too, Fahad, we've been working together for 2 years now, so how Fahad joined us as Civic Ledger is I wasn't looking for a blockchain developer. I was looking for someone who was smart, who was curious, who actually had the ability of his level of thinking. We were very grateful that he had his degree from Monash, but you had some real world experience by Monash teaching Fahad about agile, like how to work on a sprint, what it means to do agile, how do you put user stories together. But it was through those conversations that we knew that we didn't want someone to come in and know how to work blockchain, because we wanted to teach that. But we do need back end and front end, and we need all of those other places, like how do you actually work with data and looking at relational databases, but also your math. So the way that you've had to look at math through this project has been quite intense. I know that it's pushed your brain quite a few. I don't know if you've been using chat to help you with your
Oh yeah, I've been using ChatGPT if you guys have known about it. So it can run test cases for your code or even for your smart contracts. So yeah, it's really interesting. And also the data structure and algorithm courses in Monash helped me to code a lot. And also the courses, for example, project management and also agile methodologies. These are very good courses that you guys can focus on and learn your skills.
And that's one of the most important things, is that when you come to work with us as a company that builds software, what we're actually asking is, we want to know, do you have a Git? So we had a look at Fahad's GitHub, and we gave him a problem to solve. We could read his CV, yeah, we knew he'd been to uni, but we wanted to know, how do you look at a problem, Fahad? How do you code it? How efficient are you in your code? And those are the questions that we look for, because when we know that, if we know that you can actually have level of curiosity and you can solve a problem and you can code well, and you get on well with the team, because I don't interview the developers interview each other. So they actually go talk to the person who wants to, who we're looking at, and I let them sort it out, because the most important thing is that they all get on with each other. And then I come in and have a bit of a chat about the company, but I really look to the team to, because cultural fit is everything, because we have to work so closely together.
Yes, I agree with you.
So now, when you first started working with us, Fahad hardly said anything. He was so quiet, and he was very quiet, but over time now, you've just come back from Bangkok, because you've just spent 2 weeks over there with the team, with our other team over there. So how do you find that your role now, from the time that you started with us to now, you're building, the most complex.
Yeah, at the beginning, those concepts, like the water accounting concept, is very complicated. So it was like going over my head, everything. But once we start knowing the business logics, years after year, months after months working, it becomes more familiar, and then you can train the new guys when they join. You get to train yourself with the business logic, and also our product owner, who is from France, who also gives us a lot of knowledge of water accounting. So it's all about teamwork, how we work in team, how we synchronize our work, even though we are working across time zones, but we have the common timings, so where we can sit around and solve this complex problem that world is facing.
Yeah, and I think that's one of the things. So Fraser McLeod, who is, yes, he is in France, but he's an Aussie who decided to go live in France. But he used to be the technical director for the Murray-Darling Basin Plan. So when the Murray-Darling Basin Plan was getting developed 22 years ago, Fraser was one of those guys that had to have the police protection when he went to the irrigation districts to talk about water markets. So we're very lucky that Fraser is bringing all of that knowledge around how water markets work, and then working through the lens of this new technology to how we modernise that. And then he works directly with the team on a daily basis, and we make sure that we're checking in with each other. And it's very important that you feel confident to ask questions if you don't know the answer to code. And that's the most important thing too, is that you've got to make sure that you're always learning and learning and learning and learning. But Fahad's going to be here, like he lives, how many only live?
Thank you.